Welcome back to the deep dive. Today we're looking at something that, well, it takes a sledgehammer to how most of us learn to code.
Right. We all start with an integrated development environment, an IDE. It's like our essential companion.
But this research suggests that for a beginner, those tools, like IntelliJ or Eclipse, they impose what's called a tooling tax.
A tax set, yeah. They're basically black boxes, and they can actually stop you from learning real engineering.
It's the difference between learning to drive a car and, sitting in a self-driving taxi.
Exactly. The whole argument here is that before you get that big green one button, you have to build a mental model first, a notional machine.
You have to understand what's under the hood.
And to do that, this curriculum forces students to strip away the interface completely. No menus, no autocomplete.
Just a blank terminal.
Just a terminal.
Which, on the surface, that seems wildly inefficient. Why make a beginner memorize commands when an IDE has a button for it?
But that's where the sources get into cognitive load. Look, when you open a professional IDE, you're not looking at a text editor, you're staring at a cockpit.
Hundreds of controls.
Hundreds. For a beginner, that's all extraneous load. You're burning mental energy just trying to navigate the tool, not solving the actual problem.
The blank terminal gets rid of all that noise.
It focuses your attention entirely on the intrinsic stuff. Compilation and execution, that's it.
So it's a desirable difficulty. The friction of the command line is actually the point.
The friction builds the mental model.
Okay, so let's talk about that model, specifically with the toolchain. A lot of us assume the Java compiler, JAVAC, is, doing all this heavy lifting like in C++ trip.
Yeah, that's a common myth.
Yeah.
But the notes show JAVAC is, surprisingly dumb.
Dumb.
It's a translator, not an optimizer. The real optimization happens much later, in the JIT.
So what's the point of using it manually then? So the goal isn't to make you code in Notepad forever.
Not at all. It's to make sure you aren't helpless without the fancy tools.
Which is really relevant today.
Think about DevOps. CI/CD pipelines, Docker containers, there's no play button there. You're in a headless environment. If you don't understand the command line or class path, you can't build anything.
It's an imperative-first pedagogy. You master the machine, then you earn the tool.
Exactly. That knowledge makes the IDE a power tool. A lack of it makes the IDE a crutch.
So a final thought for you. Next time you hit that green run button, ask yourself, do you actually know what it's doing? Or are you just hoping the black box works its magic?
We're looking at a piece of software that it claims to solve one of the biggest headaches in computer science education.
The Hello World paradox.
Exactly. We're talking about BlueJ.
It's a really interesting piece of tech. It's an IDE, an integrated development environment built for teaching Java. But its goal isn't speed, like professional tools. It's all about visualization.
And that visualization is so key because, learning Java for the first time can be, it's painful.
It really is.
And the sources we looked at really zero in on this Hello World paradox. To write the simplest possible program, you have to type a line of code that is it's gibberish to a beginner.
Right, the public static void, main string args. What does static even mean when you're just starting? You don't know.
You have no idea.
So you're just told, just type these magic words, we'll explain it in 6 months.
Which is just rote memorization. And it creates this completely false mental model. You think you're writing a script, line 1, line 2, line 3.
But you're not. You're supposed to be in an object-oriented world, making these little digital things that talk to each other.
So most IDEs, they're objects later. You write all this code first. BlueJ just flips that completely.
Yeah, it's objects first. It kind of forces you to play with the objects before you even write the code to control them.
Let's walk through that because the whole interface is basically a metaphor for how a computer's memory actually works.
Okay, so when you open it up, you don't see a blank page. You see what's called the main window.
Think of it like the factory.
The factory, exactly. That's the static context, technically. And in there, you see your classes as these yellow rectangles. So you might have a greeter class.
And I love this little visual cue. If the code isn't compiled, the yellow box has these diagonal stripes. It looks dirty.
It's a great visual. It tells you this is just a blueprint and it's not ready yet. But once you compile it, it's clean. And then you can look at the most important part of the screen.
The object bench at the bottom.
Right. The sources call it the warehouse.
Which is really the heap, right? The place where all the live stuff in a program is stored.
Yes, it's the heap memory. And in a normal editor, that space is completely invisible. In BlueJ, it's right there at the bottom of your screen.
Okay, so this is where the aha moment happens. You don't hit a run button. You right-click the yellow blueprint.
The greeter class.
And you choose new greeter. And a red, rounded rectangle just physically appears on the bench.
That visual is everything. You see the yellow blueprint, the class, and the red product, the object, as two separate things.
So now you've got this red object just sitting there, but there's no script telling it what to do.
No, you are the script. You are the main method. You right-click that red box, and you see a list of things it can do, like say hello.
You're passing it a message.
You're manually sending a message to that one specific object. And this leads to another feature, the object inspector.
This is what really clarified encapsulation for me. You can, like, pop the hood on the red box and see what's inside.
Yeah. So let's say you create two of them, Greeter 1 and Greeter 2. You use the inspector on Greeter 1 and change its greeting to, say, bonjour.
But Greeter 2 is completely untouched. It still says, hello world.
Exactly. You just visually proved that they have their own separate identities, their own internal memory. You changed one red box, the other stayed the same. It's not an abstract paragraph in a book. You just saw it happen.
It makes the abstract totally concrete, and it does this with the code itself, too, with something called scope highlighting.
Oh, yeah, that's a lifesaver for beginners. Instead of just coloring text, it colors the entire background of a code, block white, light gray, dark gray.
So you can instantly see where your method ends. You can see the classic missing bracket error before you even make it.
It's so clever. And there's one last thing, the code pad.
It's like a little command line, a REPL.
Right, but with a twist. If you type a command that makes an object, like new greeter, a tiny little red icon appears next to your text.
And you can literally click that tiny icon, drag it onto the object bench.
And it becomes a full living object that you can interact with. It just connects everything. It shows you that the code you type isn't just text. It's an instruction that makes a real thing.
It really feels like it's just demystifying the Java virtual machine, all this invisible machinery.
That's the whole point.
Right.
It stops the computer from being a black box.
Which I think brings us to our final thought. If BlueJ makes coding so much clearer just by making the invisible heap visible, what other complex systems are confusing us?
In our lives, you mean?
Yeah, our economy, our governments, maybe even our relationships. What are we not seeing? What's the hidden machinery that, if we could just visualize it, would suddenly make everything click?
Right, we're talking about that huge gap between something like Scratch with its Fenley blocks.
Yeah, and then suddenly you're thrown into a professional IDE like Eclipse, and it's just boilerplate and config files everywhere.
It's a massive leap.
Yeah.
You go from dragging blocks to just a blinking cursor on a blank file. And that's exactly where Greenfoot comes in.
It's designed to visualize object-oriented programming, right? The docs call it a micro-world approach.
A micro-world. It's a perfect term because you're not just writing abstract code. You're building a little digital terrarium.
I like that. But before we get to the fun visual stuff, we have to talk architecture. It looks simple, but since it's Java, the setup is pretty particular.
That's a key point.
Yeah.
People assume it's just a standalone app. But Greenfoot is really an editor and a runtime wrapper for your Java bytecode.
And this is the part that trips people up. Most Java apps just need the JRE, the runtime environment, but Greenfoot is different.
It is.
Yeah.
Because you're the developer, it doesn't just need to run Java, it needs to build it. It needs the full JDK, the Java Development Kit.
The compiler tools?
Exactly, it needs JAVEC. Without the JDK, it's a car without an engine. It's not going anywhere.
And what's cool is that it's not some stagnant old piece of educational software. The latest version requires JDK 21.
Which is the current long-term support version. That's huge. It means it supports modern Java features like switch expressions, and it runs natively on Apple Silicon.
So it's not running on legacy fumes.
Not at all. It's got professional-grade plumbing. And once you have that engine running, you meet the two core pillars of the whole system, the world and the actor.
And these map pretty cleanly to what you see on screen. The world is your 2D grid, your container.
And the actor is anything that lives and moves on that grid. And the system handles all the coordinate logic, whether you want, say, pixel-perfect movement or a big grid for a chess game.
This leads to what you call the strongest feature, that interactivity. It's like a visual REPL.
Yeah, a visual read-evil print loop.
Yeah.
But instead of just printing text to a console,
Yeah, get a Wombat.
get a Wombat.
Yeah.
You can right-click the Wombat class, click New, and just drag an instance of it right into the world.
It makes that abstract idea of a class versus an object so tangible you can literally see the blueprint become a thing.
And you can poke it. You can right-click on the object in the world, inspect its variables in real time, or even invoke methods directly, like telling it to move.
Okay, but this visual first approach has to change the code structure. I went looking for the classic public static void main method, and it's not there.
That's the big aha moment for everyone. Greenfoot uses something called inversion of control.
Don't call us, we'll call you.
Precisely. You don't write the main loop that tells the computer what to do from top to bottom. The Greenfoot environment is the main loop. It calls your code when it's ready.
So what's the actual entry point then? Where does our code start?
It's the constructor of your world subclass. That's where you set the stage. And there's a really strict rule here. The very first line must be a call to super, width, height, cell size. You have to build the canvas before you can put anything on it.
Build the house before you invite guests. Makes sense. And even how the actors talk back to you is different. No more fall. System.out.println.
Well, you can use it, and it goes to a little terminal window. But the native way is to use show text.
Which just renders the string right onto the world's background.
Yeah, it keeps you in the simulation. The output is part of the state, not some external log.
And all of this is driven by the ACT method and the run button. That's the heartbeat, right? The game loop.
It is the game loop. Your ACT method defines what an object does in one single tick, one frame. But when you hit run, Greenfoot takes over, becomes a scheduler.
So it calls ACT on every single object in the world.
Over and over, about 60 times a second. It manages the whole loop so you don't have to.
Okay, so wrapping this up. Greenfoot's whole deal is removing friction to make OOKey tangible. But that scheduler you mentioned introduces a really interesting problem.
It does. It comes down to how Greenfoot keeps track of all those actors. Under the hood, it's using hash maps.
And anyone who's worked with data structures knows hash maps make absolutely no guarantee about order.
Correct. So if you have 10 wombats on screen, you literally cannot predict which one's act that will be called first in any given frame. It's non-deterministic.
That's wild. So if two of them are racing to the same spot, the winner could just be a random quirk of the hash function for that frame.
Exactly. So I'll leave you with this question. If you're building a micro world where you can't trust the order execution, how does that force you to design your logic compared to a simple linear script?
You decide, okay, I'm going to learn Java. So you download a big professional tool like IntelliJ or VS Code.
But before you've even written a single line of actual logic.
You're just drowning. Build paths, dependencies, project SDKs. It's a lot.
I mean, it's just massive friction.
Yeah.
And it's not just, annoying. The research on this is pretty clear.
It's actually harmful to learning.
It is. There's this thing called cognitive load theory, which basically argues your working memory is, well, it's a finite bucket.
Okay.
And if, say, 80% of that bucket is full of you just trying to figure out why your run configuration is broken.
Then you have no mental energy left for what you're actually trying to learn, like what a loop is.
None. That's what they call extraneous load. And it just kills the learning process.
So our sources suggest looking backward to find a way forward. We're digging into a tool called Dr. Java from Rice University.
Right. And it's designed to be what they call lightweight.
Yeah.
So to basically remove that tax so you can just focus on the code.
But looking at the specs, this isn't just a simple text editor.
Oh, no, not at all. It's much cleverer. Its standout feature is something called the interactions pane.
And that's like a REPL, right? A readable print loop.
Exactly, which is pretty rare for Java. The usual feedback loop in that language is just so slow.
Yeah, you have to write a whole class, write a main method, compile it, run it.
And then you find the bug, Dr. Java short circuits all of that. You type code, hit enter, and it runs instantly.
The example in the notes really made it click for me. Say you're trying to understand integer division.
Mm-hmm.
In a Pro tool, that's 5 minutes of setup. In Dr. Java, you just type 5.2.
And it immediately spits out 2.
Then you try 5.02.
And you get 2.5. In, 10 seconds? You've just learned about type coercion without ever seeing a public static void main.
It turns coding into an experiment.
Exactly. Not a construction project.
But hold on, it sounds a little risky to me, technically. How so?
Well, if you give a beginner a direct line to the processor like that, and they write an infinite loop, wouldn't that just freeze the whole application?
That is the brilliant part. Normally, yes, it would. But Dr. Java uses this really fascinating 2JVM architecture.
A 2JVM. Okay, so it's a safety net.
It's the ultimate safety net. It kind of separates the brains from the brawn, if you will.
Right, so you have the main JVM running the user interface,
Yeah.
the editor, the buttons.
And then a completely separate slave JVM that's just there to execute your code.
So when that student inevitably writes that wild loop that never ends?
They only kill the stunt double.
That's great.
The editor, the main JVM, just keeps running. You hit a button that says reset interactions. the slave JVM restarts, and you haven't even lost your unsaved code.
So it encourages you to be fearless. The penalty for failure is 0.
Precisely.
Okay, but we have to talk about the elephant in the room here. The sources are pretty clear about this catch.
Right. Dr. Java is old. It's legacy software.
Yeah, and it doesn't just, prefer older Java. It strictly requires Java 8.
And this is where that tooling tax kind of sneaks back in, isn't it?
It does, but in a totally different way.
Yeah.
See, when Java 9 came out, they introduced the module system project Jigsaw.
Right, that locked down a lot of the internal APIs for security.
It did.
Yeah.
But Dr. Java, well, it relies on poking around at those internal gears to work its magic.
So if you try to run it on modern Java, say Java 17 or 21...
It just crashes. Instant crash on launch. The recommendation is really specific. You need Amazon Corretto 8.
And for Mac users, it looks even rougher. The notes mention a gatekeeper gauntlet.
It's a bit of a quest. Because Dr. Java is old and unsigned, macOS just treats it like malware. You often have to go into the terminal and run Xanter commands to get the OS to trust it.
So it really begs the question, is all that hassle worth it?
I'd argue it is, but with a big caveat. Dr. Java isn't supposed to be a destination.
It's a bridge.
It's a bridge. The whole point is to isolate algorithmic thinking from, environment management.
So you learn the logic first.
You learn the logic, the flow.
Yeah.
He even has JUnit testing built right in, so you learn proper engineering discipline, and then you move on.
You use it to build that mental model, and then you graduate to the big tools like IntelliJ.
Right. You shouldn't be fighting the tool and the language at the same time. This lets you just fight the language first.
It's a compelling trade-off.
Aye.
But, it leaves me with this one final thought. As operating systems get more and more hostile to older software, and tools like Dr. Java get harder to run, are we effectively burning the bridge behind us? Are we forcing beginners into all this complexity just because we've lost the ability to run simple tools?
That's the real danger, I think. We might be optimizing for professional power at the expense of pedagogical clarity.
Well, it's a bit of a paradox, actually.
It really is.
We're looking at a tool that takes Java's, the language of boring enterprise backends of tax software.
The really rigid stuff, yeah.
And somehow turns it into a sketchbook for visual artists. We're talking about processing.
It's such an odd beast. It sits right at that intersection of rigid computer science and this really fluid creativity.
Right.
I mean, normally if you want to write Java, you're dealing with a mountain of boilerplate code just to get hello world on the screen.
The dreaded public static void main ritual.
Exactly. And it just pushes people away. So Processy's whole mission is to strip that barrier away. They call it the happy path.
The happy path.
You open the editor, type a single line of code, and you immediately get a visual result. But the trick is, under that simple hood, it is still a robust Java environment.
So it's a zero to hero journey we're mapping out today. We're going to cover how this tool forces you to rethink, basic coordinate systems, how it visualizes invisible logic, and the specific features that can turn a coder into a designer.
We have to start with the first hurdle everyone hits, the canvas itself.
The coordinate system shock.
Mm-hmm.
In high school, geometry is like the center or bottom left and the y-axis goes up. That's just intuitive.
It makes sense. But in processing, you launch the window and the y is at the top left.
And y points down?
Down. It feels completely wrong initially, but it's actually a ghost of hardware history.
Oh, really?
Yeah, it mimics the electron gun in old CRT monitors. The gun scanned pixels, starting from the top left, moving across, and then down. So to move something up on the screen, you actually have to subtract from its y-coordinate.
Which I imagine becomes a real headache the second you try to rotate something. The source has brought up transformation pollution.
That's the perfect term for it.
It sounds like an environmental hazard, but it's about how changing the grid just messes up everything else.
It's exactly that. You rotate the entire grid, say 45 degrees to draw one diamond. Well, that rotation sticks. Every single shape you draw after that is also tilted. You've polluted the global state of the canvas.
So how do you contain that mess?
You have to master what's called the matrix stack. Processing gives you push matrix and pop matrix.
Okay.
Think of push matrix as taking a snapshot of the normal world. You then enter this temporary local space where you can do your weird rotations, draw your object, and then you hit pop matrix to just wipe those changes and go back to the clean global state.
So it's basically scoping, but for geometry. Okay, so once you've mastered the grid, you have to deal with the flow. Processing has a very specific heartbeat.
It does. It splits execution into two main parts,
Yeah.
setup which runs just once to build the environment,
Right, sets the stage.
and draw, which is an infinite loop that runs, say, 60 times a second.
And this is where the visualization aspect really clicks for me. In a normal script, a loop is just, data processing. But here, a programming loop becomes structure.
It becomes visual.
Yeah, a for loop isn't just counting numbers. It's drawing a texture or a grid on the screen.
And the feedback is so visceral. If you write an accidental infinite loop in a terminal, it just hangs. But in processing, the renderer freezes solid because that draw cycle never finishes. You don't just get an error, you see your logic break.
And to fix those breaks, the sources pointed to a specific, a hero feature, tweak mode. This seems to solve that whole write, compile, run fatigue.
Tweak mode is a legitimate workflow changer. Instead of guessing a color value, hitting run, seeing it's ugly, and then restarting,
A whole cycle.
you just turn on tweak mode. It lets you live code. You can click and drag on numbers, coordinates, RGB values right in your code while the sketch is running.
So you're tuning the code like an instrument rather than just compiling a document.
Precisely.
Yeah.
Now let's scale this up from drawing circles to actual data visualization. The problem is, real-world data is messy. You might have population data in the millions, but your screen is only 800 pixels wide.
The scaling problem.
That's it. And processing solves this with the map function. It is the workhorse of visualization. It just translates a value from one domain, say 0 to 1,000,000, and it normalizes it to a new range, like 0 to 800 pixels.
It's the bridge between raw stats and your screen's real estate. And once you have that map data, you can do things like color interpolation for heat maps.
Right, using loupe color.
And loupe is short for linear interpolation.
Exactly. It calculates all the intermediate states between two values. For a temperature map, you don't just want a blue square next to a red square. Loupe color calculates every mathematical shade of purple in between to create a smooth, continuous gradient.
It's interesting. We've gone from fighting an inverted y-axis to mathematically smoothing out colors. The core insight here seems to be reification.
That's the perfect word for it. Processing lets you turn this invisible execution flow, the abstract logic of the machine, into visible geometry. You aren't just coding, you're seeing how the computer thinks.
A pretty compelling shift in perspective. So here's a final thought to leave you with. We talked about lerp for linear blending, but what about bilinear interpolation?
That's the next logical step. Instead of seeing your data as just a grid of blocky cells, imagine calculating the weighted average of the 4 nearest data points for every single pixel on the screen.
So it smooths everything out even more.
It forces you to ask, at what point does a set of jagged, discrete data points become a smooth, continuous reality? Unpacking a tool that, I think it's fair to say, really defines the modern Java ecosystem. IntelliJ IDEA Community Edition.
And it's a really necessary one.
It is, right?
Yeah, because there's still this lingering bias that Community Edition just means, leet version.
The trial. Like, it's just the training wheels you use before you get the company to pay for the ultimate version.
Exactly. But that's a huge misunderstanding. We need to be clear. Community Edition is a full-on production-grade environment.
It powers things like the Android build systems, right?
Android systems, Swing frameworks, a huge chunk of open source infrastructure. So our mission here is to shift that paradigm, stop using it like a text editor.
And start using it as an extension of your brain.
That's the goal. And it all starts with how the IDE actually thinks.
The PSI, the Program Structure Interface, the guide calls it the brain.
It is the brain. This is the core differentiator. Most editors, even really powerful ones, they see your code as text, a sequence of characters. IntelliJ, with the PSI, sees a graph, a web of interconnected symbols. It knows this method call is tied to that specific definition.
Which is why indexing takes so long when you first open a big project. I think we all know that sound of the laptop fan spinning up.
It's a heavy lift for sure. It's drawing that entire map. But the trade-off is it's massive. That upfront cost gives you zero latency features later.
Like find usages.
Instantly. It's not searching text, it's just looking up a node in the graph.
Speaking of performance, though, the guide had this great pro tip about the JVM, those little micro stutters you get while typing.
Right, the ones that kill your flow. It's not your machine.
No, it's the config.
It's the config. The IDE itself runs on Java, and the default memory can be a bit conservative.
Looking at something that, for a lot of developers, feels almost like a religious conversion.
It really does.
We're talking about this big shift in the Java world, moving away from those massive monolithic IDEs, the walled gardens like Eclipse or IntelliJ.
Right.
And migrating to the more modular, lightweight architecture of something like Visual Studio Code.
Yeah, it's a huge paradigm shift. For so long, Java development meant, waiting 10 minutes for your tool to even load up.
Oh, absolutely.
It was powerful for sure, but it kind of felt like driving a tank to the grocery store. VS Code is trying to offer you a fighter jet cockpit instead.
I love that analogy. But let's be real. A lightweight environment usually means you spend 3 hours manually setting up config files.
Well, yeah.
We have this guide here, and it's calling itself the Zero to Hero path.
Mm-hmm.
Is that actually seamless, or is it just, marketing?
It's surprisingly robust. But, and this is the key, you have to use the right entry point. The guide is really clear. You need the coding pack for Java.
Okay, but I've been burned by those intelligent installers before. They overwrite my existing settings and leave me with a mess.
No, that's a totally valid fear. This one is designed to be a idempotent. It's basically a provisioning agent. It scans your system first.
So it checks what I already have.
Exactly. If you've already got a JDK or the editor, it just skips them. It's looking for a specific state like Java 17 or higher compatibility, and it only fills in what's missing.
All right, so it handles the plumbing. Once we're installed, the guide mentions the extension pack and this thing called the Language Server Protocol, or LSP. I see that term everywhere. Why should I care?
That is the secret sauce. I mean, in the old days, your editor and your compiler were one giant program. If the compiler got stuck, your whole screen froze.
Right, the whole UI just locks up.
LSP divorces them. It puts the heavy Java compiler in its own separate, headless process.
So even if the compiler is sweating, my interface stays totally smooth.
Exactly. You get that, 60 frames per second typing experience while the heavy lifting happens in the background.
That's a huge quality of life improvement. Okay, let's talk workflow. The guide makes a big deal about the file explorer versus the Java project's view. But isn't a file just a file?
Hey, in Java, rarely.
Yeah.
The file explorer shows you the physical reality, the folders on your hard drive. But Java cares about the logical structure.
Yeah.
Packages, dependencies.
Oh.
So the project's view abstracts all that complexity away for you. It's how you want to manage your libraries.
Got it. So I'm coding, I hit a bug. My first instinct is just mash swirl plus F and search for the method name.
And that's the habit this guide wants to break. Instead of curl plus F, you use peak definition. Alt plus F12. It opens this little inline editor right where you are.
So you don't lose your place?
You never lose context. And when you find that messy code, you refactor it. But don't do it manually.
The little light bulb icon, right?
Yeah.
I admit, I get nervous letting a tool rewrite my code.
But it's not guessing. It uses the abstract syntax tree, the AST. Think of it like a grammar diagram of your code. It understands the nouns and verbs of Java.
So it knows what variables need to be passed in.
It knows exactly what to do. It's much safer than a human doing copy-paste.
Okay, I've refactored. Now I need to test it, and this is where I usually have to stop the server, recompile, restart. It breaks my flow.
And this is my favorite part of the guide. Hot code replace. You don't have to restart.
Whoa, hang on. If I change the code while the app is running, doesn't that just corrupt the whole state?
That's the magic. If you're just changing the logic inside a method, the debugger can patch the running bytecode live, you save the file, and the behavior changes instantly. No restart.
That is wild. But what if I just need to see what's happening? I'm guilty of spamming system.out.println everywhere.
Oh yeah, we've all been there. That's why you use log points. You can inject a log message right from the debugger without actually changing your source code.
Keeps the code clean.
Nice.
Okay, last thing, visualization. This debug visualizer tool that turns variables into charts. That sounds a little too good to be true.
It is fantastic, but
Yeah.
there's a catch. It relies on an external tool called GraphViz. Yeah, you need the dot binary. If you don't have that old open source graph software installed and on your path, it just won't work.
But if you do get it working,
You can turn a complex linked list into an actual visual tree diagram while you debug.
so you're basically turning debugging
Yeah.
from reading text into pattern recognition.
Precisely. You're not just using a text editor, you're architecting a cockpit.
It really changes the whole perspective, doesn't it?
Mhm.
If we can visualize memory and hot patch code live, are we still just writing code?
Okay, let's get into this. We often talk about, the lightweight editors.
Right, the super fast web-based tools.
Exactly. But when you're dealing with, say, a 10-year-old banking monolith, lightweight can start to feel a lot like underpowered.
It's a really important distinction.
So today we're looking at the heavy lifter, the Eclipse IDE. And I mean, the research suggests we might have been looking at it all wrong.
I think so.
Yep.
The sources describe it less as just a text editor and more like a full, rich client platform.
Built on that modular OSG architecture.
Yep, which is just a fancy way of saying the whole thing is a collection of plugins that act like one single app.
And that's why it can scale up so well.
It is. So the mission here is to get from zero to hero. You want to move past just, opening a file.
Right, from setup with the OMPH installer all the way to really mastering that whole ecosystem.
The ecosystem that keeps these huge legacy systems going.
Okay, so let's pop the hood then. The core of this thing is the Eclipse compiler for Java, the ECJ. But honestly, isn't a compiler just a compiler? Why does it matter if I'm using Javac or this one?
Well, that's the thing. A tool like Maven uses Javac, which is a batch processor. It compiles everything at once. ECJ is completely different. It's all about incremental compilation.
The compiler that never sleeps.
That's it. It is literally compiling every single time you hit save.
But the quotes say you can run code that actually has errors in it. I mean, that sounds dangerous. Why would you want that?
In a big enterprise app, it's a lifesaver.
Huh.
So ECJ generates bytecode with what it calls error stubs.
Error stubs, so placeholders.
Exactly. Imagine Module A is just completely broken, syntax errors everywhere. But you're working over on Module B. Because of those stubs, the compiler isolates the problem. You can still run and test Module B without fixing A first.
Okay. So you don't have to fix the whole world just to test your one small change. The app only crashes if you actually call the broken code.
Precisely. And that leads right into the other huge time saver, hot code replacement.
Right. Avoiding that dreaded server restart.
Which in a monolith could be 10 minutes. Easy. With hot code replacement, you just change a method body while you're debugging.
You hit save, and it just injects the new code into the running JVM.
It does. And you can even drop to frame.
That sounds traumatic. What's it do?
It's like rewinding time, but just for that one function. It resets the instructing pointer to the top of the method so you can rerun your new logic immediately.
Okay, that helps explain why the workspace is such a specific concept. It's not just a folder with your files.
No, it's the brain. It's a metadata database. That metadata directory is tracking everything. Indices, local history, plugin states.
So the key is to keep your Git repo, your actual source code, separate from the workspace folder itself.
Yes, that way if the metadata ever gets corrupted, you don't lose your actual work. It protects you.
And because that workspace understands the code's structure, the abstract syntax tree, the AST, it can do real refactoring.
We're not talking about a simple find and replace here.
Which is just text-based and, frankly, kind of dangerous.
So dangerous.
Yeah.
AST-based refactoring is semantic. It understands the code. Take extract method, the Alt plus Shift plus M shortcut.
A classic.
You just highlight a messy block of code, and Eclipse analyzes the data flow. It pulls it out, figures out the parameters, handles the return type all automatically.
But all of that real-time analysis, the AST, the indexing, that has to be heavy on memory.
It is, and that brings us to, I think, the most common mistake people make.
Sticking with the default eclipse.ini file.
Yep, you absolutely have to feed the beast. Go into that file and crank up the heap size.
The NashXMX setting.
That's the one. On a modern machine, give it 4 GB, maybe even 8 GB. Don't starve it.
And what about garbage collection? To stop the UI from lagging.
You can switch to the G1 garbage collector. Just add NashXX plus use G1GC. It makes a huge difference in keeping the UI snappy when the indexer is working hard.
So, give it room to breathe. We've covered a lot here, from OMPH to the AST to tuning the JVM. It really feels like Eclipse is about achieving velocity through control.
In these huge code bases, resilience is velocity. Being able to run broken code or hot swap a fix is what lets you keep moving.
So here's a thought to leave everyone with. You know how they say, the tool shapes the hand. If you're using a compiler that works incrementally, letting you test and fix in this constant real-time loop, does that actually make you a more iterative thinker? So today we're digging into a guide called The Architect's Forge, and it makes a pretty bold claim about Apache NetBeans. And I have to admit, I was a bit skeptical. In a world with VS Code and IntelliJ everywhere, talking about NetBeans feels a little dated. Why this topic now?
That's exactly it, though. That reaction is why the guide is so important. If you just see NetBeans as like a legacy code editor, you're missing the whole point.
Which is?
It's not trying to be the most popular IDE. It's the rich client platform. I mean, it is the reference implementation for Java.
So less of a competitor and more of a standard bearer.
A standard bearer. That's the perfect way to put it. The guide frames this whole thing as a zero to hero journey.
Zero to hero.
Yeah, zero is, you're struggling just to get it installed correctly, which we should definitely talk about. And hero is when you finally leverage the architecture.
Okay, let's start there with the architecture. The guide highlights this really strict quarterly release cycle, NetBeans 25, 26, always on schedule. It says this syncs with OpenJDK.
It does. It's designed to offer day zero support for new Java features.
But doesn't day zero usually mean, unstable, a bit bleeding edge?
Sometimes,
Yeah.
but not here. Because NetBeans is that reference implementation, it actually forces your code to be incredibly standards compliant. It's not adding its own flavor to the language.
So there's no proprietary sugar on top.
None. If you use a preview feature in NetBeans, you are using it exactly as the Java architects meant for it to work. It keeps you honest.
Okay, that makes sense. But first you have to get it running. The zero hurdle, as they call it. This bring your own JDK model. It feels like a roadblock.
It feels like one, but it forces you to learn something critical.
The difference between the runtime and the project JDKs.
Exactly. The project JDK compiles your code, sure, but the runtime JDK is what powers the IDE itself. And for NetBeans 5 and up, you can't just use whatever's lying around on your system anymore.
The guide is very specific about running the IDE on JDK 21 or higher. Is that just for new features? It's deeper. First off, performance. With JDK 21, you get the Z garbage collector, ZGC. For a huge application like an IDE, that means your UI doesn't freeze up while it's indexing.
Sub-millisecond pauses, right?
Right. And second, it's architectural. Modern Java has removed the old security manager. Since NetBeans relies on reflection, running it on an older JDK without the right flags will just crash. It won't even start.
So once you're past that, you have the Forge running. The guide then talks about a Maven first philosophy. Most IDEs support Maven, so what's different?
No translation layer.
What do you mean, no translation?
Other IDEs, they'll import your pom.xml and then create their own proprietary project files, their own metadata.
So the IDE's model of your project can drift from the actual build file.
Exactly. And NetBeans just parses the pom.xml directly. It is the build server, in a way, that completely eliminates the classic, well, it works on my machine, but fails in CI problem.
Okay, that's a big deal. Now, moving on to the hero tools. Let's talk about NBJavac. The guide makes a big deal about the Alt plus Enter shortcut.
Every IDE has that, though. A quick fix shortcut. Why is this one special?
It's what's happening underneath. NBJavac is a modified Java compiler that is incredibly resilient. It can build the abstract syntax tree, the code structure, even if the code is completely broken.
So you can refactor code that doesn't even compile yet.
That's the magic. You can do huge architectural changes like modernizing old switch statements across an entire project, even when half the files have syntax errors. It just recovers and lets you work.
That is powerful. Okay, what about the profiler? The guide talks about surviving generations.
Right, so we assume the audience knows what garbage collection is. The profiler here doesn't just show you a giant heap dump.
Which is usually overwhelming.
Totally. Instead, it visualizes the generation count. It highlights objects that are surviving way too many GC cycles. It finds the immortals.
So if a temporary object has survived, say, 50 garbage collections.
You've got a leak. You know it instantly, without having to trace the entire object graph.
Yeah.
It's incredibly efficient for finding those slow burns.
Efficient. I like that. I do want to touch on the GUI builder Matisse. I mean, Swing, it feels like we're talking about ancient history.
And yet, an architect needs to prototype right fast. Matisse isn't just for old apps. It handles the nightmare of group layout for you. You can drag and drop a UI to validate a business concept in minutes. It's about speed to validation.
So the real theme here seems to be that mastering the tool is about mastering its configuration.
That's the whole hero part of the journey. Mastery isn't just typing code faster. It's tuning the netbeans.com file, picking the right garbage collector, and realizing your IDE is a complex Java application that needs optimization, just like the code you write with it.
A hero developer doesn't fight the tool, they calibrate it. That's a great way to think about it. So here's a final thought for you to chew on. If your IDE is your forge, have you actually sharpened the anvil? Or are you just hammering away with the default settings designed for someone else?
Stripping the paint off a tool that millions of developers use, but apparently very few really master, Android Studio.
Oh.
And I'll be honest, looking at the source material, I've been so guilty of treating this thing like a glorified text editor. You type code, you hit run. But these notes, they suggest I'm looking at it all wrong. They call it a pocket computer.
It really is, and that's the mental shift you have to make to understand why it, behaves the way it does. When you launch Android Studio, you aren't just opening an editor. You are simultaneously spinning up a complex hardware emulator. You're managing a heavy build system with Gradle.
And indexing everything.
Exactly, indexing millions of lines of code for navigation, and you're rendering high-fidelity graphics, all at the same time.
Right. Which explains the massive performance cost and the first hard reality check in the data. Everyone has that story of trying to run this on an old laptop and the fan just starts screaming. So the official specs say 8 GB of RAM is the minimum. Is that actually viable in the real world?
It's viable if you enjoy waiting a lot. 8 GB is just survival mode. The emulator alone, which is simulating a full Android kernel, can eat, 4 GB?
Half your resources right there.
For sure. So if you want to reach that hero status the guide talks about, 16 GB is the functional floor. And SSD isn't optional anymore. It just isn't.
Okay, so assuming we have the rig to handle it, let's talk about the actual coding workflow, specifically what the sources call the Great UI Schism. We're talking about moving from XML to Jetpack Compose. Is this just, new syntax, or is it a fundamental change?
It's a total paradigm shift. I mean, a whole different ballgame. XML was imperative. You saw the UI as this tree of widgets. If you wanted to change a text box, your code had to literally go find that box by its ID, grab it, and manually mutate it.
Compose.
Compose is declarative.
Okay.
You just describe the UI as a function of your data state. If the data changes, the UI automatically recomposes itself to match. It's much cleaner.
That sounds great in theory, but that usually means a slower feedback loop. Do I still have to compile the whole app just to see a small change?
And that's the killer feature. No, you use the app preview annotation. You put that on your composable function, and you get an interactive preview right there in the editor. You can click buttons, type in text fields.
Without ever launching that heavy emulator we just talked about.
Exactly. It's a game changer for speed.
Speaking of tools inside the editor, the notes mention Gemini, what used to be StudioBot. Be real with me. Is this just another AI hype integration, or is it actually practical for a daily workflow?
It's surprisingly practical for let's call it the grunt work. There's a feature, Transform UI. You can literally right-click something and just use natural language.
Like what?
Say, wrap these buttons in a row, and it refactors the code for you. It's not writing the app for you, but it removes so much of that boilerplate friction.
It seems like removing friction is the theme here, even with the build system. We're seeing a move from Groovy to Kotlin DSL. Why does the language we use to build the app matter so much?
Type safety. That's the whole nugget right there. Groovy is dynamic, so you often don't know you made a typo until you hit build and, it fails 30 seconds later. With Kotlin DSL, the IDE understands your build scripts. You get autocomplete, compile time errors. It's just treating your build logic with the same respect as your app code.
Okay, so we've built the app, now it's crashing. The hero mindset suggests we should spend as much time mastering debugging as coding. What are we looking at beyond print statements?
We're looking at Logcat 2.0. It's moved way beyond just being a massive wall of text. It uses structured parsing now.
So you can actually search it effectively.
Right. You can filter specifically by is.crash or key value pairs like package.mine. But the real power move is the database inspector.
This is for the local SQL databases on the device.
Yeah. And it's bidirectional. So you can view your Axe database live while it's running. But more importantly, you can double-click a cell in the inspector on your laptop, change a value.
And it changes on the phone instantly.
Instantly. You see the UI update. It's huge for testing edge cases without rerunning everything.
Wow. What about performance? Jank is the enemy of every mobile dev.
That's where the profiler comes in. It visualizes your CPU threads so you can see if you're blocking the main thread, which is what causes that stuttering. It also captures memory heap dumps to find retained objects, things that should have been garbage collected but are just sticking around leaking memory.
Before we wrap up, I want to touch on this Meerkat release feature, device streaming. Because testing on, say, foldables is it's expensive.
It is. So now Google lets you stream physical devices, like a real Pixel Fold, directly from their data centers into your IDE. You get the real hardware experience without the $1,800 price tag.
Incredible. Now, the sources end with one massive red flag.
Yeah.
The ultimate warning. What's the one mistake you absolutely cannot come back from?
Losing the release key store.
Okay.
This is the private key that signs your app. It needs a 25-year validity. If you lose this file, you cannot update your app on the Play Store, ever.
So there's no forgot password link, no support ticket you can file?
None. Zero. You would have to publish a brand new app, a new package ID, and start from 0 users. Back up that file.
A very high-stakes note to end on. You know, it really feels like the role is shifting. We aren't just writing Java or Kotlin anymore. We're orchestrating this massive engineering platform, from AI transformations to remote device streaming. Definitely something to think about. Thanks for listening to The Deep Dive.